Next, we're going to talk about context engineering. Other than prompt engineering, you might also heard of a term called context engineering. And I wanted to explain why this concept emerging. It started from this technical report by ChromaDB. ChromaDB is a vector database company similar to Pinecone. So they discovered something fascinating called context rod, how increasing input tokens impact large language models' performance. And this is prevalent for all models, including very intelligent ones like Claude, Sonnet 4, and Gemini 2.5. Even if we can have models with 1 million tokens, you are still going to get degraded performance as you input more context. And the reason is that there are actually lots of things going on under the context window. For example, in the context window, you can have your system prompt. That's when your overall instructions. You can have user input. That could be the dynamic input. And for chat application, you will have in-session chat history. That is the short-term memory. And you might also store those conversations and create a compact version, and that become the long-term memory. And perhaps your Gen AI apps can use tools, and then you will include tool instructions for those MCPs. And when you are using those tools to call APIs or get response from those tools, those outputs are also under context window. And of course, if you have an external knowledge base, any context retrieved from those knowledge base is also in this context window. Last but not least, some of the models, they have reasoning capability, and the model's thinking token is also within the context window. Let me give you an example of a typical customer support application. For example, the customer might ask, I bought product X last month and it's not working. I've tried the basic troubleshooting from your website. Then immediately after that, you wanted to collect this user input as a context and trying to infer the user intent. And then you might go to a retrieval process, trying to find out the user's profile, their purchase history, and do they have any previous support tickets. And after that, you might need to call some tools to search for your purchase database or product database. And also you might want to search your knowledge base, or you might have all your FAQs and supporting documents stored in a knowledge base. And you can, based on the user query, do some vector similarity search to find the relevant solutions. After you retrieved a bunch of documents, and then you wanted to compact the context and rank them in a way that is most relevant to this user, and remove the ones the user have already tried and prioritize for the response you have high confidence. After that, you need to format your context in a way and pass it to large language model. And then the large language model is going to process all the context and generate the response back. And then you can show the results in the front-end applications. So you can see those are the final context window composition for such application. You will have system prompt, and you will have customer purchase history, product information, troubleshooting documents, conversation chat history, as well as the tools. For example, escalation, how are you going to refund, and perhaps replacement. How to do context engineering? I don't think we have a consensus for best practice yet, but I really like the one shared by ChromaDB CEO. A process, what he called is from gather to glean. For step 1 is to find all the relevant information, and step 2 is to remove irrelevant information. And step 3 is to optimize relevant information. Next, we're going to talk about AI